Hello, good evening, everyone. Welcome back to EJ Teach Tech, a YouTube channel of which we learn and teach electronics together. So please, if you are new on this channel, please do well to like and subscribe to the channel so that each time we have a new video, you will get notified. So now, today we are going to be diving into a subject known as a transistor, one of the most important components in electronics. So today we are basically going to be seeing how to turn on and turn off this transistor by the virtue of current through in the base of the transistor. So now, before we dive in fully, this is just how a transistor look like in real world. This is what you see in real life. So this is how the transistor look like. So the transistor basically is a semiconductor device which is used as a switch or as an amplifier in an electronic circuit. So majorly the transistor consists of three terminals, which are the collector, emitter, and base. So majorly the transistors we are going to be looking at today are the general purpose transistor, which are the bipolar junction transistors. So we also have other transistors such as the FET and JFET, the FET, JFET, and the MOSFET. Now look at this family of transistors. So from the word transistors, can you see we have the BJTs, we have the FETs. This is the field effect transistors. These BJTs are classified into NPN and PNPs. The NPN and PNPs, then we have the JFET and we have the MOSFET. MOSFET too, we have the N-channel MOSFET and P-channel MOSFET, but we are not diving into that today in today's lesson. So in today's lesson, you are going to concentrate on what the NPN and the PNP. But even at that, you are going to be concentrating on the NPN transistor. But anything you can do to the NPN transistor, just reverse the case, and it's same applied to the word PNP. So now this transistor can be turned on by virtue of the current in the base of this transistor. So now, definitely the first circuit we are going to be building in this tutorial video is this circuit, of which we have an LED connected to what power supply, and it will glow. So now the first thing, if you have that circuit, now before we look into that, now this is our transistor. So the transistor we are going to be using today is our BC547 transistor. Now coming to the regions of operation of transistors, we have three regions of operation of an NPN transistor, which is what the saturated region, cutoff region, and the active region. These are the three regions of which you can operate these transistors in. So this transistor can be operated in these three regions. Now, but if the transistor is operating at this region, that means the transistor is acting as a switch. But if the transistor is operated at this region, it's acting as an amplifier. So now from the data sheet of this BC547, this is the collector, this is the emitter, and this is the base. Making sure the transistor is facing you. And you see, you make sure the transistor is facing you. So this part is facing you. So this is the collector, this is the base, and this is the emitter. So now we are going to be connecting this. We are going to connecting this circuit first, of this circuit of which current will be flowing from the LED to this. So now if I connect this circuit, the only thing that will happen in this circuit is that that is my LED will be glowing. That is just it. If I connect this circuit now to the ground, so each time I on this power supply, my LED will turn on. So if you see, my LED has turned on. So if I off this power supply, it will turn off. If I on it, it will turn on. If I off it, it will turn off. So now what I'm going to be doing is that here now I'm going to be breaking this circuit and fix a transistor there. I'll fix a transistor there. So I'll now fix a switch such that if that switch is not turned on, the transistor won't glow, won't turn on. So I'm going to be fixing a switch there. So now if I'm fixing a switch here, that means if I apply this small current, I'm expected to turn on this transistor. So this is exactly what is happening, is that each time I arrange this circuit, what happens is that if I apply small current to the base of this transistor, that means the collector emitter part resistance becomes 0, telling you that there is a short. That means here and here will be connected. That means the maximum current will be flowing from the collector to the emitter. That is why in theory of transistor, most times you only see IC to be approximately IE when the transistor is switch on. But when the transistor is at cutoff region, there's no current. It's assumed that there's no current that is flowing from the emitter to the collector. So leaving the place to have a resistance of infinity, like an open switch. So now if this current is passing through this base, then a current will be flowing from the collector to the what? To the emitter. That is maximum current. So this circuit and this circuit are basically the same. This circuit and this circuit are basically the same. This circuit and this circuit are basically the same. It's just that for pure understanding when building the circuit, that's why I did this. So that's why I did this one too. So they are just the same circuit. This circuit and this circuit, they are the same circuit. So now, since we have understand that, now we are going to be building this circuit now. This circuit. Now as you can see from here, now this is my, if I on this is supposed to show. So you see, this is the ground of this. This is the ground. This is connected to the negative terminal of the LED. So this one that is connected to the negative terminal of the LED, which is to be connected to what? Is to remove it from here. So that this will be connected, this your collector will be connected to now your LED. Can you see? It's connected to my what? LED negative terminal. So without current flowing to the negative terminal, that means this LED won't glow. So now, what will happen is that what? Then the emitter will be connected to the ground. The emitter of the transistor, this third leg, will be connected to the ground. Then the base will be connected to a resistor which is 10 kilo ohms from the circuit. Then now this 10 kilo ohms will be connected to a push button. Can you see? I connected to the push button. Then the push button will be connected to the what? VCC. So now this transistor, this light won't turn on except I input a current to the base of this transistor. And this current that I will be inputting to the base of this transistor is by the virtue of what? Me pushing this switch. Because this push button is push to make. Each time I push, a current flows from the base to the base of the transistor, making the transistor to turn on, then this LED will glow. So now if I turn on this now, can you see? I push to make. So if I push it, it turns on. If I leave it, it turns off. If I push it, it's turned on. If I leave it, it turns off. So as you can see, this is just the simple way of what? Of turning on and off of a transistor. On, off, on, off. By the virtue of the current flowing through the base of the transistor. I've explained earlier that when a small current is flowing to the base of the transistor, it makes the transistor to be what? Saturated. When the transistor is saturated, maximum current flows from what? Collector to emitter. And if there is maximum current flow from collector to emitter, it's just like a short circuit. So that means there is current to be flowing from the collector to the emitter. So basically that's how a transistor is being turned on. I hope this video helps and this video really assists. So I hope you get something from this video. So thank you, and always stay creative and always like and subscribe to our channel, and I will see you next time. So take care.